Lesson 61, subsets. So we already learned about sets. They just look like this. We have a letter that is labeling a bunch of numbers that are in between some of these brackets, and that would be a set of numbers. So a subset, here's the definition. If all members of one set are also members of the second set, the first set is a subset of the second set. So let's look at these numbers here. 1 and 2 are the set of B, and they are also in the set of A. So therefore, B would be considered a subset of A because it has the same numbers that are in A. So I can write that out as B is a subset of A. And we use this symbol to say is a subset of. However, A would not be a subset of B. So I'm going to take that and just cross it out. And that means is not a subset of. And A can't be a subset of B because of this 3 here. It has something that's not in the B. Now we can also talk about proper subsets. So because there are some things that are only in set A, like this 3, I can say that B is a proper subset of A. That just means that set B can be properly contained in set A. It fits in there somewhere, but there are other things that are not a part of B. Now let's add another set. Suppose we have set C, and that is defined as 3, 2, 1. Set C would be considered a subset of set A, since all members of C are the same as the members of set A. We can even go so far to say that set C and set A are equal sets to each other because they have the exact same members. Now it's important to note that equal sets are considered improper subsets of each other. Now let's think about it this way. We had proper subset would be B and A because B does properly fit into A. It is properly a subversion of A. It's not completely A, but it would be a subset. But if they're exactly the same, then why would you call it a subset? It's just an equal set. You wouldn't really have to call it a subset because it's the same exact thing. It's like having me come in as your substitute teacher. You wouldn't really call me a substitute teacher because I'm not subbing in for anything, I'm just me. So if they are equal, they are improper subsets because they're not really a sub of anything. If it's actually a sub part of something like B and A, that is a proper subset. Now, if we were to have a set with no members at all, that can be called a proper subset of every set that has ever existed. It can basically fit into anything, right? It doesn't have any numbers, so therefore it's a set of every single thing. This is how we would denote the empty set. And this is what we would also call a null set. Null just means nothing. It's just a set of nothing. So I can say that this empty set is a subset of our original A. It can be considered a subset of A. And I can also say that the null set is a subset of A. This set is considered to be a subset of every single set in existence. Now let's try an example. Okay, given the following 3 sets, tell which of the following assertions are true and which are false. And then we're going to talk about why. So number 1, is E a subset of G? So let's look at E. E has 1, 2, 3, and it continues on and on. G has 1, 3, 5. So I need to know if all the things in E also exist in G. And that's definitely not true because E continues on and on forever and G only has 1, 2, 3 numbers. So that is false. B. Is G a subset of E? Well, let's think. This one contains 1, 3, and 5. E also contains 1 and 3, and I can assume that it also contains 5 because it looks like it's just going to contain every single counting number. So that would be true. All members of set G are also members of set E. Now, is D a subset of set E? Let's look at D. Does it have all the same things as E? D has 1 and 2, and E also has 1 and 2. But D has 0, and E does not have 0. So therefore, D cannot be a subset of set E. That would be false.